Welcome back to the video. In this video, we'll be talking about discussing a question on simple harmonic motion. Now, this is a really interesting question, and it is actually not that hard either. So we have a simple harmonic motion that this spring mass system undergoes, and they've given us the mass of this trolley that is moving around in simple harmonic motion, and that is 810 grams. And it says that the trolley is displaced along the line of the two springs and then released. And then we have the acceleration of the trolley given to us by this following equation. And they have given us the spring constant of each spring as 64 Newton per meter. They have told us the displacement x is of the trolley. And now they've told us to find, for part A, the frequency of the trolley. So I think this is going to be for 3 marks maybe. Okay, but either way, you know that acceleration is equals to minus 2kx over m. And we also know one of the key equations for simple harmonic motion is A is equals to minus omega square x as well. So if I equate both of these equations, I'm going to get minus 2kx over m equals to minus omega square x, and then what I'm going to do, cancel the minus out, and then I'm going to cancel the x out, and I'm going to get my equation as omega square is equals to 2km. Then I'm going to solve for omega, so I'm going to plug in all the values, the mass as well. I'm going to convert it to kg, and I'm going to get my answer as 12.57 rad per second. Now I know that omega is equals to 2 pi by f. Now I know that the frequency is equals to omega divided by 2 pi, so it's going to be 12.57 divided by 2 pi, and that's going to give me my frequency as 2.0 hertz. And that's what we needed to show. Okay, now next part. The maximum displacement of the trolley is 1.6 centimeter. Maximum displacement simply means the amplitude. So whenever you see this word in exam, remember, whenever they use the word maximum displacement, they want you to find the, they have given you the amplitude, or they want you to find the amplitude, okay? Now, they want you to find the maximum speed. So one of the formula for speed here, the velocity is v is equals to minus a omega sine omega t. So if I plot a graph, the sine graph, it's going to be the minus sine graph, then I can see the maximum velocity value will occur here. And if I say this is the time period t, then this will be t by 4, right? This will be t by 2, right? And then this will be 3 by 4t, and this is 0t. So you can see that we're kind of making our way towards t. So this here will be t by 4. So I can say sine, at the maximum velocity, sine, and then omega I know is 2 pi by the t, which is, now here there's a difference. This t and this t, there's a difference. This capital T is the time period. So 2 pi by the time period will give me the omega value times. Now my t value that I'm going to substitute in will be the time period divided by 4. So you can see this cancels out, and this becomes sine 1 by 2 pi, which is just 1. So then I get my velocity formula as minus a omega. And then from here, I know that the amplitude is 1.6 times 10 to the power of minus 2. And I know the omega value is 2 pi. And then I know the f is 2. So it's just going to be 4 pi. And that gives me a speed of 0.2 meter per second. Okay, the next part. The mass of the trolley has increased. The initial displacement remains unchanged. Suggest a change, if any, that happens to the frequency and the maximum speed of the oscillations of the trolley. So what we know is omega is equals to, now we had the formula above, is omega square is equals to 2k over m. Now if my mass has increased, that the omega value goes down, right? So the omega value will go down, and then omega we know is 2 pi by f. Now if the omega value goes down, the f value has to also go down. So our frequency decreases, and we know that the maximum speed formula is V is equals to A omega. And if the omega we know is decreasing, then the speed maximum will also decrease. So this also decreases. Okay. Alright, so that's the question. Not too difficult, pretty easy. That's all for this video.